Hello, I'll be going over this integral. So with this integral, if we do use substitution in the denominator, it's not going to really work in the numerator. So we're going to have to do trig substitution for this. If we see this, the denominator resembles a secant inverse function. And you would remember the derivative of a secant inverse function is the square root of the x and the square root of the 16. So we can write it as the secant theta equals x over 4. Okay, so now if we solve for x, we're going to have x for secant theta. Okay, so now we're going to derive it to find out what's the dx. So the dx is going to be d theta for secant tangent theta. And now we can draw a triangle to draw the relationship between all these functions. So the hypotenuse, which is going to be the x, is going to be right here, the adjacent here, and then this will be the other leg. So x squared minus 16. So now it's good that we pair it with tangents because secants and tangents tend to be derivatives of each other. So that should be the best way to do it. So we do this too. Square root of x squared minus 16 all over 4. That's the same thing as tangent theta, because right here is the theta. And then if we solve for this to get a match to the denominator, because look right here, this is being the square root. This 4 goes here. So now if we rewrite this with all the trig functions, we have 4 secant theta to the third. The dx is right here, so 4 secant theta tangent theta d theta all over 4 tangent theta. And look, this is being cubed to a cube. So now if we simplify this to make it a little neater, we have something like this. This 4's can actually go away. This 4, let's bring it outside. Then this secant can be combined, so the secant to the 4th, and then this tangent can actually just go away, and we can subtract 1 from the tangent, the denominator. You have tangent theta square theta. So now if we try a u substitution in the numerator, that's not going to really work because we have 2 secants. But that's fine, because what we can do, we can represent the secant squared as a Pythagorean identity. So we can rewrite this as 4 integral tangent square theta plus 1 squared, and then the tangent theta goes right here. So now if we expand this, we're gonna have tangent to the 4th theta to plus tangent theta plus 1 all over tangent square theta. And now what we can do, we can actually just individually take the integral of them. If I rewrite this integral in a more simplified form, so you know what I'm talking about, I have the tangent for theta all over tangent square theta plus 2 tangent square theta tangent theta plus 1 tangent square theta. Oh, d theta. Okay, so now let's simplify this. So we have this thing right here, and let's spread let's distribute, the integral. So we're going to have 4 tangent square theta. And then plus 8, because I'm going to take these 2 out and take these 4, so it's going to be 8 theta d theta. I meant to put d theta right here. And then for the last one, we should have 4 theta cotangent theta, because it's the same thing as cotangent square theta, d theta. So now let's individually do them. So if I take the 4 tangent theta d theta, so that's the same thing as secant. Oh no, I'm sorry. That's not the same thing as secant. This doesn't really have a clean integral to it. So what we have to do, we have to let's represent it as a trig identity. It's a Pythagorean identity. So it'll be 4 secant theta minus 1. And then if we do this, if we solve for this, this will be, because this will be tangent, so it will be 4 tangent theta minus 4 theta. Okay, so we have the first term. So now let's do the second one. So plus 8 d theta, and this is pretty easy because this is just going to go away. Like these things are going to go away by the fundamental thermal calculus, and then that's going to be 8 theta. That's really straightforward. And now, if we do the last term, plus 4 cotangent square theta d theta. Again, there's not like a clean rule for this, but that's fine because we have the identities. So this can be rewritten as cosecant square theta minus 1 d theta. And then, the integral of cosecant is negative cotangent theta minus, oh, look, I forgot to distribute the 4, minus 4. Look, there goes a 4 right here, 4 theta. Okay, so now let's combine everything together. So we're going to have 4 tangent theta minus 4 theta plus 8 theta minus 4 cotangent theta minus 4 theta. Okay, so if this should be the entire integral of what we started, but we're still not done. So let's simplify this. So look, if we take this 4 right here, and this 4, that's gonna be a negative 8, but we have a positive 8 right here. So all of this can go away, and we're just gonna be left over with 4 tangent theta minus 4 cotangent theta, right? So let's go back to our triangle, because this is not the final answer. If we go back, let's write our results right here, right next to, so it'll be 4 tangent theta and then it will be minus cotangent theta. Okay, so if we see the relationship of the triangle, we see that tangent is, opposite over adjacent. So this can be rewritten as 4 times the square root of x squared minus 16 all over 4. This can go away actually. And then minus 4. This will just be the opposite because it's cotangent. So we still have this 4 right here. So it would be times 4 all over x squared minus 16. And now if we clean this up a little bit, it should be square root of x squared minus 16 minus 16, or the square root of x squared minus 16. Oh, plus c. And then, yeah, that's pretty much it. I mean, yeah, the process can be a little long. Yeah, I'm zooming that out if you want to follow the whole thing. But overall, it's just recognizing that this represents a secant. And yeah, thank you.